No, I don't know. Yes, now it's recording. I'm there in the corner. Yeah, I'm gonna keep my face there just to make you more focus on what we have here now. It's a shorter video. This one, don't worry. We have hidden giants. Good. So hidden giants are obviously using non-renewable energies. Good, really simple stuff. This page, um, kind of slowly. Good. Things to learn here. Hidden giants use thermal energy produced by burning fuel and transform into mechanical energy. So we have to change from chemical energy to mechanical energy. The following diagrams show how heat engines are classified. This is really important chart we have to learn from the exam. Yes, good. Now we have three columns. Heat engines. There are alternative and rotating, internal combustion of the engine, uh, external combustion. Okay, we have two different combustions in alternative, two different combustions in rotating. Good. Hidden giants. What we call alternating hidden giants here have pistons which create alternating linear motion, and a rod and a crank mechanism which transform alternating linear motion into rotational motion. And then rotational hidden giants create rotational motion directly. Okay, good. Explain that, Marcos. Good. Um, so this is an engine. Imagine that. Yes, we have a piston. Yep. And a crank. Yes, we put gasoline here, and then we burn it, and we have, yes, we have these emissions. Now, this is linear because in the explosions we move backward this, and then another example of the next phase is that this cylinder is down, not up, is down. So the crank is now turning into a side, and this is generating a circular motion. Yes. Next step will be this one. We have here the piston, and then circular. We have it now here, sorted. And then the next one is actually, the movement will be this one. Well, I'm gonna sort it four times. Sorry, this one, good. The next one will be yep. I don't know how to use this pad. Yeah. Yes, so we have here in the right, then in the center, then in the left, for example, and then it's going up. It's going up, so we have this circular motion here. Yes. So from linear to circular, this is the meaning of alternative one. Rotating and hidden giants create rotational motion directly. So what we burn in actually in a plane is the turbines that are rotating on the jet engine. So they're spinning the the how you call it, the fan, like a fan, the different parts of the fan, and moving the plane towards. And the turbines are the same. The the burning is generating a rotation. We don't have, like here, we don't have linear to circular. Okay, that's the difference. Now, internal and external. We have an engine where we burn the fuel, and and then we have a movement. And an external combustion, we don't have an engine. Yes, we only have uh, like, if you remember, when you have a steam engine in a train, they put coal, yes, in a kind of a fireplace, and then we heat the water, and the water is moving the the wheels, the transmission from linear, like here, this linear, to circular. That is moving the train. The turbines is the same. We put a fire. I don't know how to write it. Yes, there's a fire, and then we have water, and then we have smoke that is moving a turbine. Yes, and that's it. And we don't have linear, just moving turbines. Four stroke here, four stroke. I'm gonna make it more thin. Four stroke, one engines, and two stroke motors. I'm gonna explain it later on. Yes, but that is really simple stuff. Good. Mm, heat engines here. Heat engine takes chemical energy. Yep. Heat engine take chemical energy and transform it into thermal energy used to generate movement. So thermal to mechanical. We will do an exercise in class, steam engines. That these ones, if you remember, are the ones that are moving. Do you remember the train? Yes, these ones. Oh, yeah, the train. This is steam engines. Good. Steam engines use the expansion of water to create by burning a fuel to generate mechanical energy. The invention of the steam engine was used to power trains. That's the most common one. Boats, industrial machines, and even the first cars. Yes, in the Industrial Revolution, we started using these engines. We are not; they are not very efficient. A diagram of how a steam machine works is included in the activity. This shows the basic components of which it is made. The boiler, yes, what I told you, the, we boil the water, the motion, mechanism to transform the motion. Um, the boiler makes the steam off by burning a fuel, usually coal, carbon. Um, the vapor enters the engine cylinder, which causes the piston to move in two directions. Yes, can you see? This is the piston. So the steam entrance. Yes, we heat the the, the water. Yes, enters here and is pushing the piston in this direction. Yep. And we have a bulb here. Yeah. So first, water vapor enters through the intake at a high pressure and presses through the distributor to the right side of the cylinder, to the right side in yellow. Right side is pushing. Um, Through the distributor to the right side of the cylinder. The piston is moved to the left and the vapor is escapes through the outlet from the left side of the piston. Left side of the piston. Yes, in this part. A steam exhaust. So we have here a hole. You can see here. Yes, and then the steam goes. Yeah. This, when the distributor changes position, the vapor continues to enter through the intake. Yes. Intake on the left of the cylinder, pushing the piston to the right, pushing the so another color. This one, can you see here? This one. This is a really important piece. Um, Part of the mechanism. Well, the distributor, which is the distributor changes position, the vapor continues to enter into here. Yes, into here. So this is the distributor when it's moving in this direction. Yes, so it is moving all the time in this direction. So this is moving the cylinder in one another direction. Now, because the water vapor in red is entering into here, yes, is pushing the piston in this direction. So we have a linear movement. Now here, in the first step. Yes, now, good. Now, okay, we didn't finish, I think. With the forces, these forces the steam on the right side to exit from the outlet. So we have again the movement of the previous um, steam goes in this direction. So what we see here actually sometimes is not, we have like normally here we have two extremes. One is water vapor from the engine and the other one is from the carbon. Yes, from carbon, sorry, coal. Yes, this is CO2, this is water actually. When it is very white, very white, very white smoke is water. So this is water. Yeah, but to obtain this steam, to obtain this one, we have to burn coal. Actually, good. Now, look at the following diagram showing how a steam engine works. Put the type of energy transformation taking place in the boxes and explain in detail how each part of the engine works. The boiler, combustion. So we transform some kind of energy into another. And this, and this, and this. Okay, we will do this in class. So just for you to introduce for next video, this is a four-stroke engine. Okay, so it has four phases. These ones are the ones here, cars and trucks, and then the other ones, the jet engines and the steam turbine. I will explain it later on. Yeah, jet engines and steam turbine. These two, jet engines, and turbines. The two-stroke motors are very basic ones from in relation with the four-stroke. Good. Well, I hope you enjoy that and you understand. If you have any questions, I'm in class. Okay. Enjoy your day. You're great students.